Hello, good afternoon, everyone. Thank you very much for staying so late. You know, I always thought that the most difficult session is when you're standing between people and their lunch. I was wrong. Now I'm standing between you and the last session, which means you need to go to the hotel, get a change of clothes, maybe go to the party. So I really appreciate that you guys staying over, and I hope I'll make it worth your while. So today I'm going to talk to you a little bit about some of the threat research we do within HPE Network and Threat Labs. So I head up that group, and our main focus is really about looking at threat actors and what they're doing, how are they attacking networks. The goal of it eventually is to transfer all that knowledge into the products that we use to build a security stack. The goal is to defend your networks. Right. So we're going to focus today on one particular topic, and that is the one of ransomware. And the reason we're focusing on ransomware is because I'll walk you through the ecosystem of how that whole thing works, and you will see that there are opportunities where you can detect, disrupt, and block ransomware attacks just by looking at what's happening on the network. By no means this would mean that you get rid of your endpoint detection. It's not what I'm trying to say. But the network has fantastic opportunities to identify those kind of attacks as they're happening, and we're going to show you how. The other thing I will mention at the early on, but I'll come back to it a little bit later, is the fact that I'm only going to have time to focus on one approach, one detection method. But I'll show you at the end that there's a pipeline of things that we can do, that we already do, and that will be a much better solution to cover the danger of ransomware. So I'm not going to talk to you about roadmap. Everything I will say today is about things that already exist in HPE products. So there's no need for this, but I'm supposed to flash it for a few seconds. So we're getting through that. So how are we going to go through this particular presentation? And feel free to ask me questions whenever you want, right? Let's make this interactive. So I'm going to talk to you about what happens in the ransomware ecosystem, not from the perspective of what you see being published, because usually it's very little. You hear that companies have been breached, you know there is a ransomware, you have no idea how it happened. Most of them would tend to hide that stuff anyway. So I'm going to talk to you a little bit about the ecosystem behind it. That's a key element. Because if you want to defend against it, you need to know how it works. It's like trying to solve a crime by just looking at the evidence and not knowing how the criminal underground works. You need to bring the two things together. What you know from the modus operandi of these people and the artifacts that you have to deal with. When these things come together, that you stand a better chance of solving the problem. One of the things we're going to use today is threat intelligence, and more specifically, threat feeds. You're probably familiar with them, but we're going to talk about how are they built. By the time I finish that part of the conversation, every one of you should be able to identify what is the fundamental flaw in the way we build threat intelligence today. Then I'm going to move on to tell you about what's a better way of building threat intelligence. How can I be a little bit more forward-looking, be a step ahead of the threat actors? And then we'll talk about some examples, right? I'll give you examples of real life, things that we have seen in defending networks from our own customers, okay? So before I get started, and in order for me to kind of adjust the depth of the conversation, I would like to get a sense within the room who believes that they are an expert in cybersecurity and who is on the other end of the spectrum. I only do networking, I'm only interested in this thing because it's a ransomware. So who knows cybersecurity and does cybersecurity for a living? Wow, we have a good section. That's perfect. Very good. Thank you very much. Great. So let's talk a little bit about ransomware. First, you hear about ransomware in a lot of context, and some of it has morphed over the years, right? So the first kind of ransomware is the one we tend to refer to most of the time lately when we hear the word, and it's the crypto ransomware. Crypto ransomware, for those who don't know, is when some threat actors infiltrates your network, gets access of the file server, and then encrypts all the files, changes their file extension into something funny, and then asks you, hey, you want your files back? You got to pay a ransom. That's the crypto ransomware. But there has been other kinds of ransomware over time. One of them is the locker ransomware. You see that more often in mobile devices, where the actual malware is going to lock your device on you, and you have no access to it. We've seen it also happen on PCs, where people see a screen, there's no way to get out of it. You reboot your machine, it goes back to that same locked screen, and there's nothing you can do unless you pay the ransom, and hope is the key word, that it gets released. The third kind is the scareware. We don't see that as much, but it's still relatively prevalent. This is the kind of ransomware where somebody sends you an email, for example, and says, hey, this is the FBI or the Internal Revenue Service, and you have to pay a fine, otherwise we'll come and arrest you. And they'll put some additional information in there that'll make you believe what they're saying. So that's the third kind of ransomware. We call it a scareware. The last one is the leakware. And the leakware is when you receive an email from someone, and they'll make it look very legit. One way they do that is by making it look like it's coming from your own account, so that you feel you're infiltrated. Somebody has access to your email, sending you an email from your own email account and telling you, I have access to all your browsing history, right? And that's when you start thinking, where the heck did I go last? And the idea there is that they'll scare you enough to tell you, unless you pay a ransom, I'm going to leak all that information to your entire list of contacts, friends, family, whatever. So in order to avoid embarrassment, you are likely to fall victim of this scam. Now, we've seen this happen. As a matter of fact, it happened to me like a couple of months ago. And I was like scratching my head. How could somebody be sending an email from my own account? Of course, it was all fake. It's coming from a server from someplace where people don't really check for SPF and things like that, and it just gets through. At the end of the day, there's nothing real about it. But the focus today is going to be on the first one, mostly because that's the one that's most prevalent. So let's talk a little bit about the threat actors behind all these elements. So this is kind of the statistical information that we have for, I would say, January to October of this year. And this is talking about the most active ransomware groups. Now, we know there's about 90 ransomware groups that have been active this year alone. So there's a lot of them. It's a real problem. To be honest with you, when I look at statistics like this, something in the back of my mind says, if somebody else comes up with a different list of most active ransomware gangs, I would not be surprised. Because it really depends on how do you go about measuring this thing in the first place. Sometimes you go by what's in the news. Sometimes you go by the leak sites. How many active groups in leak sites, how many of them have attacked victims, and how many of them started posting leaked documents in there. Other times, this information comes from incident response. A number of organizations have incident response teams. Whenever an attack happens, pick up the phone, call somebody and says, I have been breached. I need you to come and help me. I need you to come do some forensic investigation. Get me out of this problem. Restore my files. So these kind of organizations also keep statistics. So it really depends where you come from at it, but you'll end up with some numbers. If they don't match somebody else, don't be alarmed. All these groups are active no matter what. So the ones that we have here, the killing group, for example, targets mostly US local and state government, and they do the exfiltration thing first, and then they do the encryption. Akira has been extremely active recently. We're just talking here about the way they infiltrate networks. They obtain valid credentials. They buy them from the internet. And we're going to talk about some of that ecosystem in a minute. Medusa also is one of the, I would say, the crazy ones. These guys have something a little bit special. They'll tell you have to pay by a certain date. And if you tell them, it'll take me more time to gather, it's like, oh yeah, that's fine, we can wait. $10,000 per day. Every day you want to delay the leakage of your information, it's $10,000 more. So it becomes an incentive for you to try to resolve the problem as soon as possible. Now, one thing we have to understand is the proliferation of ransomware attacks is not due to the fact that a number of people have become really wise and started building their own ransomware and attacking organizations left and right. That's not why. It's because it's an industry that has matured to the point where there are multiple players that act in different roles within this entire ecosystem. The ones that we hear the most about are the ransomware as a service organizations. These organizations take care of handling the infrastructure, the malware distribution, the keys for encryption, the communication infrastructure with the victims, and the data leakage. And then you have the affiliates. The affiliates are the ones who actually do ancillary work. They develop, for example, keyloggers, or they develop information stealers. And they're also the ones who identify what victims are out there, and they could even be the ones that are conducting the actual attack. Then we have the initial access brokers. These people have a very simple life. All their job is to figure out how to infiltrate organizations, whichever way. Usually by stolen credentials, sometimes by identifying the attack surface and figuring out which devices are on the internet and which ones have vulnerabilities and whether there are exploits for those vulnerabilities. That's all they do. They don't attack. They just provide that information as a service. We're going to come to this in a moment. But most of these guys kind of work together as an ecosystem to bring about a particular attack. So the Luma C2, for example, is a known malware that is specifically built to steal and harvest credentials and push them to a command and control server in the hands of one of those access brokers. Most of the time, these kind of things come with additional malware, because not only they want to be able to steal your credentials, but sometimes they want to preserve some kind of remote access or a backdoor. So that's why things like the Quackbot, Picabot, Darkgate, and Iced ID, they come about because they're the tools that allow the attacker to install additional malware on the servers where they have already a foothold. So if we take one particular example, and I'll tell you why I'm listing this one in particular. Black Basta had a number of logs that got leaked, about 1 year worth of their logs, of communication logs, that got leaked. The cybersecurity professionals learned a lot out of just looking at the logs of their chats. So that's how we know, for example, that they're a Russian-based group. That's how we know that they're organized almost like a real company. I mean, they have developers, they have QA testers, they have product managers that define what the requirements for the malware should be. You name it. They have DevOps people who run the infrastructure. It's a real organization. And the funny part is that many of the people who work for those organizations do not even know that they're working for a criminal actor. They think they're just employed by an enterprise, just a regular enterprise. You know, it's a software company. We build tools. Some of them figure it out and get wise. They may want to get out, but some of them don't, ever. So this is just some information I wanted to share with you about how all this ecosystem kind of works together, right? So now the next thing here is relatively important. How many of you guys know about this MITRE ATT&CK framework? Yeah, decent number know. That's great. So the MITRE ATT&CK framework is a formal way of saying what are the different stages an attack goes through, and how is my enterprise dealing with each one of them. So if you're looking at defending your network and making sure you don't have any gaps, you might use the attack framework, for example. Say, hey, in this first section that deals with initial access, what tools do I have in place? How can I identify an attempt for initial access? Do I have anything that will prevent malware execution in the second phase? What about persistence? Do I have any kind of monitoring that looks for, newly created remote access jobs or new services that are created on my endpoints that shouldn't be there? Do I have monitoring for that? So each one of these steps is an area where you can apply some best practice to figure out whether you're covered or not. The more you cover, the better you are usually. And from a network perspective, that's really important because we're going to identify which ones of these do require external communication. Because that's when you can catch the bad guys. It's when they're doing that network communication. So if you want to know a little bit more about how these attacks work, I suggest you go to this website here. It's the website that my team kind of runs. We have video demonstrations of a number of attacks reproduced. All these attacks are real. They all happened last year. What we do is we take that attack, we completely replay it into our lab, and we observe and make sure that the products that we have would be capable of identifying the attack without any human intervention, without any new signatures being written. Nothing. Just by using the machine learning algorithms that we have in our current products, we want to make sure that those attacks will be identified. So you will see the demonstration in these videos. But let me go back to this ecosystem and the way it works during an attack, because that's when we're going to identify what can we do about it with this whole notion of threat feeds. So one of the first elements that needs to happen is that credential harvesting. Remember, they most of the time need to steal legitimate passwords in order to gain access. So when that credential harvesting is happening, and by the way, this is not like, oh, somebody sent me a phishing email, I clicked on the wrong link and I put my credentials in there. That's not what I'm talking about. That would have been like an initial intrusion point. But your account and your account may not be the interesting ones. That's not what they're going after. They're going after high privilege admin accounts. So once they get into the network, they need to be able to move laterally, get onto machines that are interesting, harvest credentials from there, and then they exfiltrate them. So that exfiltration is what I'm talking about here. Right, so there needs to be a communication from some victim device to the outside world in order to push those credentials. The second one here is the compromise itself. I talked about a few malware, the Trojan droppers. That malware needs to be able to download secondary payloads. And that secondary payloads needs to be able to communicate with the command and control center to send some information about the environment where it's being executed. All of that is opportunities for detection. As long as it's going through the network, it's an opportunity for detection. The last one I'm going to mention here is the data leakage or exfiltration of data that happens just before the encryption. If you're facing ransomware, if it happens to be one of those double extortion, as we call them, double extortion means I'm going to exfiltrate your data, and then I'm going to encrypt it. So now I can tell you, oh, you want your data back? Pay up. Oh, you also want me not to leak all your data to the rest of the world? Pay up some more. So that's the double extortion. So that's another opportunity for us to identify whether the threat actors are doing something nefarious or not. So far, so good? You're with me? All right, awesome. Let me talk about threat intelligence now. At a high level, what I'm talking about here is the threat feeds. Most of you must be familiar with threat feeds. They're lists. Lists of IP addresses, list of domain names, list of file hashes, URLs, whatever, it's a list. And most of the time, we use them for either blocking access, explicitly allowing access, or sometimes monitoring. You might want to say, I'm going to decrypt anything going to this IP address. Or vice versa, you can just say, I'm going to ignore decryption for anything going to the bank. Fine, but they're lists. In the case of threat intelligence feeds, they're built for the purpose of blocking. And that's the whole idea. If I know that a certain destination is bad, I want to be able to block it before the communication happens. So, but how are they built? I don't like this buildup of slides. Okay, there we go. So there are literally 4 different sources people build threat intelligence from. The first one is passive sensors. Passive sensors means I'm going to make a deal with, let's say, AT&T, or some company that sees a lot of traffic, Cloudflare, for example. And I'm going to deploy a sensor in their environment, passive, not doing anything, but only observing. That sensor could include IPS rules. Something that says, if I'm seeing a download of executable files, I'm going to flag that source. Maybe that source is up to something, especially if I see, oh, look, there's a bunch of executables being downloaded from this server, but they all have a .png extension. Something's fishy. So that's going to trigger a rule in that IPS rule set. That rule is not going to do anything to the traffic, but what it's going to do is flag that IP address or that domain name and be put in a list that says, this domain is pushing executables that are hiding as images. Okay, that's one way to do it, passive sensors. The second one is malware analysis. The malware analysis is when you get your hands on a malware. It could be because you have a tool that detected it, or it could be because you're just a research institution that has access to a ton of malware. You go to VirusTotal, you can download a whole bunch of malware. Now you take that malware, you sandbox it, you observe its behavior, and then you draw all those IP addresses it's connecting to, you draw all those domain names it's connecting to, and you put them in your threat feed. There's, of course, a little bit of cleanup that needs to happen, but ultimately, some of them will end up in a threat feed that says, you know what? If you get infected by this malware, it's going to try to contact that IP address because it's hard-coded in there. So that's another source for threat feed. The third one is honeypots, and this is something my team does a lot of. You deploy honeypots. These are systems all around the world, in various places, various networks, and you just monitor what hits them. Most of the time, you get scanners. Yeah, gray noise. Sometimes you get exploit attempts, and those are the more interesting ones. So you pick up the source of the address and say, this source is an attacker, and it's trying exploits. I'm going to put that IP address in my threat feed for today, which means if anybody gets a connectivity from that IP address, I'm just going to remove it. I'm just going to ignore it. The last one is incident response. I talked about incident response a few minutes ago. People get hacked all the time. So they call some company that comes and helps them with incident response. Experts come in, they do forensic analysis. They extract, again, useful information about where did the attack come from, where was it communicating, where do we think the command and control is, and they put all that information into threat feeds. So take all of this together, put it all into one threat feed, and that's what gets sold by some companies. That's what gets put into open source threat intelligence as well, in some situations. Then everybody can take that feed and start using it for blocking access. Now, this is the key question. What do you guys think is the flaw in this approach? Too late. Absolutely. It's a bit too late. Now, I'm not saying we throw all of this away. Don't get me wrong. This is still useful to some extent. But it is too late. You're dealing with information that is built based on past observed behavior. What you want to protect against is future behavior, not past behavior. Those guys who are doing this, they're not dumb. They know that as soon as they put something out there in an attack, within hours, maybe a day at worst, everybody knows about it and it's blocked everywhere. They cannot reuse the same thing in multiple attacks. So the key question becomes, how do we build predictive threat intelligence? The same kind of feeds, but now that kind of looks forward, looks at what infrastructure is likely to be used in the future for attacks. Okay? Wouldn't it be nice? Wouldn't it be nice if we can identify all these IP addresses and domain names, et cetera, based on what we predict is going to happen in the future? Now, why do we think this is even possible? Right? Why do we think this is possible? It's relatively simple. Attackers, they want to test their infrastructure because they're not going to attack a large corporation based on something they've never tested. This would be an operational mistake. So they have to test it somehow. Are they going to use the exact same infrastructure? No, absolutely not. But they'd use something. Now, we have an opportunity when we see that test traffic to expand from that and think about other infrastructure that the same people could be using. And one thing I want to call out here in all of this is this notion of passive DNS over here. Passive DNS, for those who don't know, is basically a database that keeps track of all domain name resolutions over time. If you go to a company that sees enough of internet traffic, well, you might see every domain name that's being resolved. It's never the case, right? Nobody has full visibility over the internet. But some companies get pretty close. Not 100%, let's just take 50%. I'll take 50%. I'm not looking for perfection here. So we'll come back to that passive DNS. The question that remains is, what is the size of the opportunity? I mean, are we talking about smoke here, or is there some real advantage in us trying to even do this? So based on the study we have done, this is what we're finding. The first spike on this chart shows one particular attempt at testing an infrastructure from the cat DDoS botnet. You can see that it has been used sometime around January, early February maybe, and then it dies down because the test phase is completed. Then it comes back up in April, and that's when real attacks are happening. Now, what happened in between? The green line shows when that particular IP address, or domain actually in this case, shows up in the first commercial threat feed. That's when people realized, oops, something is happening, let's put it in the threat feed. You can see it's already a little bit too late based on attacks. The blue line is when it shows up on VirusTotal. It says, yeah, now everybody knows about that domain name. It's actually pretty bad. Okay, but what is the size of the opportunity? The opportunity here is everything between January and April. If we had enough insights, we could have had that domain name into the threat feed from January. Why wait until April, until we have some victims? Now, is that even possible? Yes, it is possible. Let's talk about how we're going to do this. And we do this by a method we call amplification of threat indicators, of compromise. And this is a multi-step approach. There we go. So what we do is we start with known threat feeds, with known indicators of compromise. And this could come from that test infrastructure, right? They're low-key, low volume, but they're there. We select the relevant ones. And I'm going to go through each one of these steps in a little bit more detail. We select the relevant ones because there's no point in working with everything you have in a threat feed. Then we go back to query our data sources, the main one being that passive DNS. Once we're done with that, we obtain a much larger data set that we need now to pare down to something more realistic. And I'll tell you why we need to do that. And finally, we identify the associations between what we think is malicious. And that gives us a new threat feed, an amplified threat feed. Eventually, we do a validation. Is that a necessary step? No, I don't think so, but it's a validation. If you're doing research, it's good to validate that your data is not leading you down the wrong path. So let me talk about each one of these things in detail. So most threat feeds, when you get them initially, they're not perfect. For example, we find a lot of DGA domains in threat feeds. You guys familiar with what DGA is? You guys know domain-generated algorithms? Just a quick word about that. When malware tries to communicate with a command and control server, if it uses a fixed domain name or server, it becomes very easy to block. Because as soon as you block that domain name, the malware is dead in the water. It cannot communicate anymore. So how do they get around that? The malware will generate a new domain every, you name it, every day, every hour, whatever they want. But let's take an example, every day. Generates a new domain name based on an algorithm and a seed. The threat actor has the same algorithm running on their side with the same seed. Now, the two algorithms running on both sides will always agree on what the domain name should be today. The day they want to attack, they'll go and register that domain for that day. So the malware can connect now. So for you, if you're trying to block it, you have no clue. It's like every day changes. How are you going to follow up? Right? You can't. So they use this thing called DGAs. But DGAs are notoriously useless because they're not registered. You can find thousands of DGA domains that never come to existence. So there's no point in amplifying that. So we remove these, we remove duplications and all of that. So that's what I mean by selecting indicators. Oh, by the way, one thing that was really cool. We find that it's about an order of magnitude between what's useful for amplification and what's truly in a threat feed. So for every 10 entries, you actually discard 9. Then we look at the passive DNS data. And the passive DNS data, what we're trying to do is go from a domain name, figure out what IP address is it resolved to in a particular window of time of interest. Then from that set of IP addresses, go back and figure out how many domain names we're resolving to those same set of IP addresses. Now, the issue with that is an explosion, right? You could start with like 1 or 2, and you may end up with 10,000. That would not be very good, because threat feeds don't work very well if they're so large. So we needed to know what size of a problem are we working with. And it turns out that in the 50th percentile, meaning like if you look at half of your threat indicators, you end up with an average of 2 or 3 IP addresses for each domain. And for each IP, you may end up with like 9 domain names associated with that IP. So that's very good, actually. That means we can work with that kind of a data. The next one is the filtering step. And in the filtering step, what we're trying to do is eliminate infrastructure that we're never going to block regardless. If you have an IP address that belongs to Cloudflare, you better not block it, even if malware is coming from it, because the next hour it's going to belong to somebody else, and you're going to be blocking legitimate traffic. So we have to remove some of the obvious ones. And we do some additional, telemetry, like we look at the popularity of the domains, how many times have they been queried and how often, and there's a number of things that go into that approach. The last one here is we identify some associations. And again, I don't want to go into too much detail, but what this means is what tells me that this domain name, which I was able to link to another domain name, may have some association or not. And this is when we use some machine learning algorithm that's been trained. And one of the features, for example, is, are they using the same approach? Are they both dynamic DNS? Are they both in the same TLD? Some threat actor who's registering domains in the .tk, they'll probably register 1,000 of them, but they're all going to be in the .tk. They're not going to flip-flop between TLDs. So now we have the association. Finally, we do some sort of validation. This is just a test. This does not go into any production network for this validation step. And what we found when we were doing our validation is, let's just take the green stuff in here, which is the domain names. In the domain names, what we found is about 70% of the amplification that we create shows up somewhere else as suspicious. People don't really know, but they say it's suspicious. Another, 20-some% is completely undetected. It's like we know nothing about these domains. And an extremely small number shows up as harmless. And as you know, harmless doesn't mean harmless. Harmless just means that we've never observed something bad happening from there. That's all it means. But for us, the validation was the fact that we didn't see a large number in the harmless. Let's say, for example, we did this experiment, and we end up with 90% being in harmless. We'd be scratching our heads, like, did we really do the right thing here? That's not the case, fortunately. So this kind of have proven that we are down the right track. Now, let's look at some sample results. The top section here is for domains. The bottom section is for IPs. So what this is saying is, in a threat feed, domains come in and get flushed out. On average, what I mean is 83% of domains tend to stay in a feed between a week and 30 days. Whereas IPs tend to stay actually a lot longer. IP addresses, once they get into a threat feed, they could be there for like a year. As you can see, like 32% stay between 6 months and a year in a threat feed. And that's relevant to us, especially when we're talking about, when we're talking about commercial feed indicator lifetime. Now, the associated infrastructure, after we do all our filtering, what we're finding is at about a 90 percentile, we end up with maybe 100 times more in terms of IPs, and a similar count in terms of domains. That means you start with a feed which could have like 1,000 entries. You end up with one which has about 100,000 entries. So that's still within the realm of something that's possible to manage. Right? So there you go, nine indicators, average 9 per IP indicator and 13 per domain indicator. That's the expansion. Very few of them happen to be in the long tail, right? The one that ends up with 1,000 plus. And those are usually not good ones. That means you didn't do a good filtering at the very beginning. Chances are this belongs to a CDN. So we'd have to go back and filter. So the question then becomes, what is the potential for early indicator given the lifetime of the feed? What are we gaining? Right? So you got to look at it from both a domain and an IP perspective. So what you want to know is the surface area on the graph, which is like if you're talking about the domain names, 75% of the domains are observed before they show up in the threat indicator feed. That's the potential for us to grow, right? The threat indicators using amplification. And the median there is about 33 days. So we should be able to know in 75% coverage about a month before a domain name gets used in an attack. What about IPs? IPs, it's even more because 86% of the IPs are observed by passive DNS before they show up in an indicator, which means they were already resolving bad domains to those IPs before the IP shows up in the threat indicator. So the opportunity there is even larger. And the median, I think, is about 6 months. Right? It's like half of them are longer than 6 months. The other half is less than 6 months. So that's huge, right? And then we wanted to say, you know what, let's run this and see how it goes. Obviously, we didn't put this in production directly. Could have been, catastrophic. You never know with these kind of things. So what we did is we ran telemetry on real customer traffic, trying to identify these things in somewhat of a silent mode, right? We just want to know, are we hitting any of those amplified threat feeds or not? And the couple of cases that I want to talk about here is one particular attack which happens to use this WebDAV in order to download a bat file. Let me build up this thing. So this is just talking about the entire attack so far. So there is a Python installer, downloads a variant of async-rat. By the way, this happened multiple times. That's why you see variant of XWorm, async-rat, venom-rat, because the same malware actually does all of these variants depending on where you see it happen. The bottom line is that final connection to a CNC server, could we have detected that? And this is a real-life example of what happened. That first domain name you see on the left is a domain that was in a threat feed. When we amplified that, we looked at passive DNS data. It happens to expand into 2 IP addresses. And then we said, okay, what other domains have ever been associated with those 2 IP addresses that are similar of nature? Again, this is where the ML comes into play to try to find that similarity. We found, what is that, like 10 domain names, right? And we said, okay, great. Let's take those 10 domain names and let's add them to our threat feed and see what happens. And sure enough, these indicators, those 10 domain names, fired off at 2 separate customers of ours. So this was an indication that the amplification of the threat feed actually helped in a real-life scenario before those domain names were known to anybody else being used in any attack ever. So that was real validation for us. Now I want to conclude with this. What did we talk about so far? We talked about ransomware groups using evolving tactics and potentially evolving infrastructure, but they need to test some of it. So we do have some visibility. We're not completely blind. But we also said that the traditional threat intelligence is helpful, but not 100%. It's never going to be bulletproof. So we have to augment that somehow. And we've proven that this amplification method that we put into HPE's products is actually helping in real life. Now, the one thing I want to go back to, which I said at the very beginning, is given the time we have, I'm not here to explain all the methods you have to use in order to prevent ransomware from succeeding in your environment. This is just one. But if you look at the rest of the security stack that we have in our products, you start with everything that's threat intelligence based because it's the simplest thing you can do, right? You have your file reputation, your IP reputation, your domain reputation, your URL filtering. Still, apply all of that, no problem. And then you get into a little bit more complex attacks where you have to use a little bit more advanced engines. IPS is one of them. We have something called AI predictive threat prevention. These are a couple of engines that exist on the SRX 4700 firewall, which do machine learning on the fly, on the box, on all the files that get transferred through your network, and try to identify zero-day attacks. So these are things never seen before, and we're still able to identify them on the device. So far, you have not used the cloud yet. Well, we do use the cloud to build the models, but then they're pushed to the device, and then the device is on its own. When all of that fails to identify an attack, we still have the advanced threat prevention, which does involve the cloud. Now, any file you're trying to transfer goes to the cloud. Any suspicious DNS query you're trying to do gets sent to the cloud for additional analysis. That's when we do things like DGA detection. Some DGA detection happens on the device itself, but some of it gets completed in the cloud. DNS tunneling is identified there too, because a lot of the exfiltration happens over DNS tunneling. So all of that comes in ATP Cloud. The bottom line is the security stack is comprehensive enough to cover so many use cases. The videos I mentioned to you guys a few slides earlier are proof of that. But today, it was all about threat intelligence. How is it built? Why is it flawed? How can we make it better? And I think that's all I wanted to tell you today. Please give us some feedback.